Hi, and welcome to our 118th test and measurement video. Today we'll demonstrate some phase relations in two sine waves. They are generated in this Tektronics AFG 1000 series arbitrary function generator and conveyed via BNC cables to this Tektronics MDO 3000 series oscilloscope. To speak meaningfully about phase, you need two waveforms, or with a single waveform, you have to be speaking of a change that takes place over time, or a change in some condition, such as with and without a specific load. For example, the current waveform lags behind the applied voltage waveform when the load is inductive, and the current waveform leads the applied voltage waveform when the load is capacitive. That is because reactance in a circuit is a function of the rate of change in voltage, not the actual voltage level. As you can see by looking at the sine wave, the rate of change is greatest when the voltage is least. As the trace crosses the x-axis, and the rate of change is least when the voltage is greatest at the positive and negative peaks. That is the way a sine wave works, and it is a consequence of the rotary nature of the generator. Now let's look at some phase relations. In the arbitrary function generator, frequency, phase, amplitude, and offset all have default values. The default value of the phase is 0 degrees. So you can see that the waveforms of the two signals are in phase. The peaks and the zero crossings occur at the same points in time, and all intermediate values correspond precisely. Let's leave the phase of the signal shown in channel 1 at the default setting and change the setting of the waveform in channel 2. In both instruments, the dedicated color for channel 1 is yellow, and the dedicated color for channel 2 is blue. The AFG displays only one channel at a time, and you toggle between the two by means of a button on the front panel. Both channels transmit to the oscilloscope simultaneously, but you have to switch between the two channels to display them in the AFG or to change their settings. So now the AFG is on channel 2 and will change the phase of the sine wave. You can use either the touch screen or the number pad. We'll enter 90 degrees, and as you can see, the peaks of each waveform correspond to the zero crossings of the other. This would be the situation in a purely capacitive load if you measured the voltage with a probe connected to channel 2, and you measured the current with a current probe connected to channel 1. Now, turn back phase to 0 degrees. The oscilloscope analyzes the relationships between two waveforms in the XY mode, in which their Lissajous figures are displayed. Two signals are required. One of them is connected to the channel 1 analog input. Using the old cathode ray tube terminology, after suitable amplification, the signal is fed to the vertical deflection plates, so that at any instant its amplitude is shown. The other signal is connected to the channel 2 analog input, and it triggers the signal, creating in the oscilloscope display the Lissajous figure rather than the familiar time domain display. So with the two sine waves from the AFG still connected to the oscilloscope, press the Acquire button in the front panel. Then in the Horizontal Acquisition menu, press the soft key associated with XY display. In the vertical menu, press Triggered XY. There is the Lisa Ju figure of the two in-phase sine waves of the same frequency and amplitude. If you toggle YT on, the time domain display of the two waveforms appears in the top screen. As you can see, the Lisa Ju figure for two in-phase sine waves of the same frequency and amplitude is a diagonal line going from the bottom left to the top right in the fourth quadrant. Now let's change the phase of the sine wave connected to channel 1. Keep your eye on the time domain display also. Here is the Lisa Ju figure when the phase is set at 90 degrees, a perfect circle. As you might expect, when the phase is set halfway in between, at 45 degrees, the Lisa Ju figure is an ellipse. And when the phase relation is set at 180 degrees, the Lisa Ju figure is a diagonal line beginning at the top left and descending to the bottom right. By way of comparison, let's see what happens when we change the frequency. The default is 1 megahertz for both channels. So we'll cut the frequency signal in channel 1 in half to 500 kilohertz. The Lisa Ju figure is a sideways figure 8 with two lobes. And 250 kilohertz generates 4 lobes. Let's double the amplitude to 2 volts peak to peak. Thanks for watching. New videos are added periodically, so check back frequently.